Before Rutherford, J.J. Thomson had already discovered the electron, and so he proposed his famous plum pudding model of the atom, where the electrons are like a negatively charged plum that's in the center of this positively charged batter, which is the pudding that's holding everything in place. Now, Rutherford's gold foil experiment basically contradicted J.J. Thomson's plum pudding model, because if the plum pudding model were true, then that means that Rutherford wouldn't have seen the results that he saw in his gold foil experiment. He proposed a revised version of what the atom should look like, and what he thought the atom should look like is a small nucleus that's positively charged, that's orbited by electrons that were negatively charged, like how planets orbit the sun.
Rutherford's new model of the atom really formed the basis of nuclear medicine. He's often described as the father of nuclear medicine. He not only described the structure, but also described decay, so alpha decay, beta decay, or different types of atomic decay. And we use the principle of that decay to actually form the images that we see. So the new model of the atom allows us to use positron emission tomography, and that really tells us about the activity of cancer cells. And so if we use an example of this patient here, we've got a bright area. This is located within the tongue, and we know that this is an area where the tumour is located, and this other bright area here is an area that it's spread to. So if we didn't have the model of the atom and we didn't know about positron decay, we wouldn't be able to get these images.
One of the things that I do is measure water pollution using light and using a technique called spectroscopy. So without the new atom, we wouldn't be able to understand how light really interacts with molecules and atoms. That means that we wouldn't really know, when we look at the color of something, how that relates to what is happening inside those molecules, because molecules are so small we can't see them. We rely on things like what color they are to tell us about what the electrons are doing inside of those molecules.